Global warming, a looming threat with its repercussions being felt and seen increasingly as the days pass. Human contribution is accelerating these effects of climate change, one of which is an increase in extreme weather events, such as flooding. More specifically, global warming is expected to increase flooding risk by altering the distribution, variability, and intensity of these precipitation events. As it gets warmer, more water from the ocean or on land in bodies of water evaporates, contributing to these increased storms. So then comes the question, how can we mitigate this enlarging risk? The most widely used and effective method to mitigate flood effects is the construction of dams. Hydroelectric energy collection and flood control are the two main reasons dams like this one in Oroville, California were created. By releasing water in controlled amounts through spillways, dams can prevent a flood altogether in nearby towns, like Oroville. Hydroelectric energy also mitigates these floods by reducing the amount of energy needed from fossil fuels and replacing it with renewable energy collected from flowing water. Across the globe, there are an estimated 2.8 million dams, with total water impoundment capacity ranging from 7,000 to 10,000 kilometers cubed. About half the Earth's current river systems are regulated by dams, showing our extensive use of them to protect people settled around bodies of water like rivers. With the increases in water due to more frequent precipitation, more dams are going to have to be built. And with more than 3,700 dams in construction or planned worldwide, it is clear that work is being done to keep the riverfront and nearby communities dry. When a dam is constructed for the sole purpose of flood control, the reservoir of water sitting behind it is kept at a low level or no water at all. This way, if a flood does happen, then the reservoir can fill up, and the water behind it can be slowly released into a river downstream. That way, instead of the surrounding communities having to deal with massive property damage and destruction of their town, the water stays in the riverbed and flows at a safe pace. In a research paper titled Role of Dams in Reducing Global Flood Exposure Under Climate Change, the authors used a H08 model to calculate the effectiveness of dams in reduction of floods. An H08 model is a grid cell-based hydrological model made up of 6 submodels, namely land surface hydrology, river routing, reservoir operation, crop growth, environmental flow, and water abstraction. They combine this with the use of a CAMA flood, a global river routing model that uses daily runoff as an input and uses that information to calculate the inflow from upsell streams and outflow to downstream, therefore predicting the evolution of water storage needed for dam reservoirs. Using these models and simulations, results revealed that populations exposed to flooding below dams decreased by 16.3% and 12.8% respectively, compared to the RCP simulations not considering dams. According to their findings, a decrease in number of people exposed to floods due to the implementation of dams was the highest during the last decade of the 21st century for both simulations. At the current rate global warming is occurring, the water holding capacity in the air increases by about 7% per every degree Celsius, increasing the water vapor levels globally, which produces more intense precipitation events. With the rising temperature and water volume in the atmosphere bringing an increase in the amount of rain coming from storms, the size of these reservoirs comes into question. Riverfront communities need to start thinking about how they will either increase the volume of the reservoir or build another dam downstream without drastically impacting the ecosystem, while also considering simulations like the CAMA flood and recent rainfall trends. When looking at increasing a dam reservoir volume, you need to consider the infrastructure that is already surrounding the lake, such as homes, parks, and businesses. To move these people and places is very expensive, not to mention the cost of labor and materials for actually digging out more room for the water. The other option of building more dams up or downstream also has its share of drawbacks. Dams change the ecosystem of a river by changing or stopping the flow of water, sediment, nutrients, and biota from upstream to downstream. Also, in the reservoir, The still or slow-moving water can heat up by sitting in the sun all day, leading to temperature fluctuations that can harm sensitive species living in the river-turned reservoir. With no clear solutions known, it is important to invent new ways to either slow down global warming or increase the volume of behaviors to accommodate for the worsening superstorms.